Welcome to Smart Learning. So today's topic is hypocycloid. So we already discussed the hypocycloid and epicycloid and cycloid, the definitions and introduction part. So this is we go to direct diagram of a hypocycloid. So what is the basic? Hypocycloid is a curve traced by a point on the circumference of a circle which rolls along another circle and inside it without slipping. So a hypocycloid curve is traced by a point P on a circumference inside the circle without slipping. It travels one revolution is called hypocycloid, and this one is inside the circle, directing circle, and this one is rolling circle, and we need a theta value. So calculate theta value. Theta is equal to 360 into small d by capital D. Okay, here the small d is rolling circle diameter and capital D is directing circle diameter, which is given in the question direct. So a hypocycloid is traced by a point P on the circumference of a circle which rolls inside the circle along the another circle without slipping. It travels one revolution is called hypocycloid. And coming into the question, here draw a hypocycloid of a circle of diameter 50 mm which rolls inside a circle of diameter 180 mm for one revolution. Also, draw a tangent and a normal to the hypocycloid at a point 50 mm from the center of the directing circle. So, here given the diagram is draw a hypocycloid curve. So, hypocycloid is the inside the circle which rolls hypocycloid is nothing but a circle inside rolls inside a directing circle for one revolution. And here diameter is given, d is equal to small d is equal to 50 mm, and inside the circle of diameter also given 180 mm, that is directing circle, and it is given to the one revolution. Also draw a tangent and normal to the hypocycloid at a point of 50 mm from the center of the directing circle. So this is the question. So write down the first given data. First given data, circle rolls inside the directing circle for one revolution, which is given into the direct question. You have to write the given data. And second one is rolling circle diameter d is equal to 50 mm and small r is equal to 50 by 2, nothing but 25 mm. And third one directing circle diameter capital D is equal to given 180 mm, and here capital R is equal to D by 2, that is nothing but 180 by 2, nothing but 90 mm, which is given in the direct question. And next you have to substitute in the theta value. So what is the theta formula? Theta is equal to 360 into small d by capital D. This is the formula, and you have to substitute this formula. Theta is equal to 360 into small d means 50 mm and capital D means 180. So then we got the theta value is equal to approx 102.8 degrees. This is the theta value of theta is equal to 1.2 degrees. So we are writing the given data, and we have to draw the diagram with the same dimensions. Take the scale, take the pencil, and circle rolls inside the directing circle for one revolution. So we need a directing circle diameter d is equal to 180, that is nothing but small capital R is equal to 90 mm. Draw a length of the 90 mm of the height from O point. This is the O and this is the first P point. This is O and this one is P point. The P point should be in the 90 mm. And next from O to P, divide the angle of 102. Place a protractor on the O point. 0, count the from the left side. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100 plus 200, not 1 and 2.8. Only 1 or 2.8 can measure, madam, only. So you have to do only 100.2. Place a point here and mark a distance of 90 mm to point 0.90 mm means 9 centimeter. Next, this angle is theta is equal to 1 or 2.8 and take a compass with the radius r is equal to 2.5. R is equal to 2.5. R is equal to take a measurement 2.5. Take r is equal to small r is equal to 2.5 radius with the draw a circle that is inside the circle of hypocycloid. Inside the circle, take a radius of r is equal to 25 mm. Then you have to divide the circle divided into 12 equal parts. Take the measurement of half of the radius. Cut the arc upside and right side. Similarly, same. Change the centers. After that, you have to join the points. And you have to write the names of clockwise direction. Why? Because this is the hypocycloid. The circle or inside the circle is rolling, so that's why inside the circle is rolling, that's why it is clockwise direction. 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, 6, 7 prime, 8 prime, 9, 10, 11 prime and 12 prime and P prime are both are same, and this is the Q point. Now take the compass. O as a center, from P as a radius, extend your compass pointer, and P as a radius, that is a 12 prime, draw a arc. Draw a arc. You're gonna touch with the Q point. Similarly, 11 prime as a center, change 11 prime, O as a center, 11 prime as a radius, and it gonna touch with the 1 prime as a point with through the directing circle, that is Q point. Similarly, 10 prime and O as a radius, draw a arc, it gonna touch with the 2 prime up to Q point. Next, P 9 prime as a radius, O and 9 prime as a radius, and draw a arc, it gonna touch with the line of Q point. And 8 prime and O as a radius, draw a arc. Seven prime and O as a radius, draw another arc. Similarly, O prime as a center, draw a arc. Yes, and you have to highlight the 9 prime and 3, that is the center of the circle, that is the center of the circle, you have to dark it. That is a dark it. This is the then you have to divide the angle into 12 equal parts. Take a compass with a convenient radius, cut the arc on OQ point and similarly OP line. Again you have to change the centers from OQ center, take a convenient radius, draw a arc. Similarly this one you have to take a change the radius, change the center, cut the arc, already drawn a arc. Just join the up to Q, P and Q points. P and Q points. We got a 1 point. That is the center. Similarly, you have to do the 12 equal parts. So after that, it divided 12 equal parts. The angle of divided into 12 equal parts. The circle also divided into 12 equal parts. Give the name of C0 and C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. Next, the point is R is equal to 25 mm radius, R is equal to 25 mm radius, and centers C1 to C12. Centers will be changed. The radius is fixed. Similarly, you have to cut the first line and second, third line. See, R is equal to, take the radius is equal to 2.5. This is the fixed radius. R is equal to, given in the question also. C1 as a center, cut the first line. Where is the first line? On the above side is the first line. Cut the first line, and that is the P1 point. Similarly, C2 as a center and R is equal to 25 mm radius, cut the second line. And similarly, C3 as a center, cut the third line. C3 as a center, R is equal to 25 mm radius. And C4 as a center, and cut the fourth line. C5 as a radius, cut the fifth line. C6 as a radius, cut the sixth line. Similarly, you have to cut the same, centers will be changed. C6 as a center, cut the sixth line. C7 as a center, cut the seventh line. This one is the seventh line, cut the seventh line. C8 as a radius, cut the eighth line. And C9 as a center, cut the ninth line, that is the center of the line of the circle. And C10 as a center, cut the 10th line. And C12 as a center, cut the 12th line. Then give the names of, and same arcs, you have to give the names of P1, P2, P3 point, P4, P5, P6, P7, P8, P9, P10, P11 and P12 and Q point. Then join the points with the help of free hand from P1 to P2, P3, P4, P5, P6, P7, P8, P9, P10 and P11. Then after that you have to dark the curve line, that is the hypocycloid curve, and this is the hypocycloid curve. Is given the question, so we have to draw at a point 50 mm from the center of the directing circle. Draw a tangent and normal. So take a compass with a 50 mm radius, okay, O as a center. Cut the hypocycloid curve on a 50 mm of the distance, and that point should be on the M point. From M to draw a radius R is equal to 2.5. R is equal to 2.5. Take a radius from M as a center. Cut the center of the circle, that is C0 line, that is point X. From X to join a PQ line. From X to join a PQ line. Yes. From O to the arc is 50 mm on the epicycloid curve. Draw a arc, that is a M point. From M to draw a 25 mm radius on a center of the line, that arc is X. From join X on PQ line and O point. Then extend the X to PQ line, that point is N point. Join N and M, that is normal, and draw a perpendicular line, that is tangent. This is the epicycloid curve.